Welcome to Blockchain in Fintech, our first digital currency related webinar. And today's session will actually be led by Dr. Reza Ghorbani. So some of you might have heard, but in a partnership with the Division of Financial Institutions, last month, HTDC launched the State of Hawaii's first ever pilot program called the Digital Currency Innovation Lab. And this program allows approved digital currency issuers to do business in Hawaii without obtaining a state money transmitter license. The reason for us doing this pilot program is for us to gain a deeper understanding of digital currencies so that we can determine economic opportunities for Hawaii and also help us inform legislation around digital currencies as well. There are more details available on our website, and we are now accepting applications for the program. So feel free to check out htdc.org for more information. Without further ado, I would like to welcome Dr. Reza Ghorbani, our speaker for today. Dr. Reza Ghorbani is an associate professor in the Department of Mechanical Engineering, and he's also the director of the Renewable Energy Design Laboratory, in short called RED Lab, at the University of Hawaii at Manoa. Dr. Ghorbani received his undergraduate and graduate degrees from the Department of Aerospace Engineering at Sharif University of Technology in Tehran, Iran. And his PhD in Mechanical Engineering from the University of Manitoba. His current research interests include power systems and smart grid technologies, as well as the design of hybrid power systems, energy management methodologies, and large-scale renewable power integration to the grid. Also happy to share that all the registration fees that we collect through today's event, Dr. Ghorbani will actually be donating it to the RED Lab, the Renewable Energy Design Lab, to support graduate student research. So without further ado, I'm going to let Dr. Reza take over, to start his session on what is blockchain and how is blockchain applied in fintech.
Thank you, Ellen. Let me share my screen. All right, so thanks, Ellen, and thanks to Michelle for organizing this webinar. So I've been working on renewable energy and smart grid technology for a while in Hawaii, and we have been working on problems related to game theory and later on transactive energy. That I have a PhD student who is working on transactive energy and tries to basically use blockchain technology in transactive energy. So that's why I got interested in blockchain itself and its in various applications of blockchain. And that's why I started to learn more about it. And I was thinking that it might be useful for more people in Hawaii to know about it. And as we have this digital currency innovation program as part of the lab, I think, I hope we will see more applications and more usage of blockchain technology in Hawaii. So this webinar is mostly very introductory and just go through the concepts and different components that involves in blockchain. And basically, the audience in this webinar are the one who tries to learn a little bit more about blockchain and see what's going on inside and see if they are interested to learn more about it or they are interested to apply it in their applications. So, so let's define money. So since we are talking about the fintech, let's look what's money. So if we look at the definition of money is a current medium of exchange in form of coins and banknotes, or coins and banknotes collectively. If you look at the brief history of the money, we started as a human, we started bartering dates back to tens of thousands of years ago. Around 9,000 to 6,000 BC, we saw bartering of animals such as sheep and cattle, and then with the development of our agricultures, we used grains and other plants as form of exchange. Around 1200 BC, we saw use of cowrie shells, mostly in Pacific and Indian Oceans. And then around 1000 BC, around 1000 BC, we saw China began to use bronze and copper to imitate cowrie shells at the end of Stone Age. When we moved more on and when we became more advanced and modern, around 500 BC, we used precious metals such as silver and gold and bronze, and we adapt them for exchange of multiple things in most in the modern societies at the time, like Persians, Greeks, Macedonians, and Romans. And then around 800 AD, we saw the first recorded, I don't know why, I think is on timing. So we saw the first recorded of use of paper money in China. And around 1816, England adopted the gold standards in which the banknotes would represent a certain amount of gold. That was the first time in Europe that the paper money was linked to directly to the gold. And then US adopted the Gold Standard Act in 1900. And by the Depression time, Great Depression time, 1930, we saw a phasing out of the gold standards. And then we saw the beginning of international monetary regulations. At the present time, we do all these transactions, and most of them actually take place electronically without ever seeing any physical cash. So everything is basically transferred to our small computers. So what gives the money its value? So most of the money today are referred as fiat monies, and basically its value is based on the value given to it by those who accept that money. And there are three different ways that we give value to money. One is how much the dollar will buy in a foreign currency, like exchange rates. And then the forex traders on the foreign exchange market, they determine the exchange rates. And then they basically take into account the supply and demand, and they factor their expectations of the future as well. Another way, the value of the money is the value of the treasury notes. They can be converted easily into dollars through secondary markets for treasuries. The third way to give value to money is through the foreign exchange reserves. That's the amount of dollar held by foreign governments. And the more they hold the money, the more they hold the money, the lower the supply becomes, and the lower the more, and then basically that makes money more valuable. And if the foreign governments were to sell all of their dollars and treasury holdings, then the dollar would collapse, and perhaps the money would, the dollar would be worth much less than today. But when we compare the cryptocurrencies with fiat money, the cryptocurrencies like fiat money can be used as a medium of exchange. The main difference is that unlike a fiat currency that is issued by a central bank, cryptocurrency is not issued and controlled by any central institution or any central body. So governments and banks, they can decide to print a new fiat money, but in the cryptocurrencies, and as an example, Bitcoin network, they have a finite amount of coin to be issued over time. And this policy never changes. And if you look at the federal tax, from federal tax purposes, virtual currencies are treated as a property. So general tax principles applicable to property transactions apply also to transaction of cryptocurrencies or virtual currencies. And but while, as I mentioned, the fiat money seems to get a major part of the value from the debts, that's not the case with cryptocurrencies, and especially with Bitcoin. So these cryptocurrencies have their own intrinsic value beyond the trust of the community. So trust is needs to be built as part of the creation of these cryptocurrencies. And Bitcoin basically doesn't lean on a system of debts. Its value boils down to how effective is a medium of exchange. And one barrier, basically big barrier to usage of cryptocurrency outside of the world of speculative investing is the usability of the cryptocurrencies in traditional payment scenarios. So the more that we use them, the better. But if you look at the cryptocurrencies, there are different terms that we have to know that I'm going to explain a little bit. Blocks. Basically, blocks is like a page or a record or a ledger. So blocks are the files where data concerning a digital currency network is stored permanently. So that's a block. The blockchain is when we put the blocks and list them together. I have to fix this. See, my slides are on timers, and I have to turn off the timers. 1 second, please. I don't have the timer here. Second, why? So I think my slides are on timers, so and it takes a while for me to figure out how to remove it. So I will continue on this one. Sorry about that. So basically, when we put this block together in a chain and list all of these transactions together in a peer-to-peer network, we call them blockchain. And mining is a way that's most of the time is computationally intensive process that as computers or nodes in the blockchain network or in a cryptocurrency network completes to verify the transaction records. And in return, the miners receive a digital coin or they receive a fee as a compensation. So I will explain the mining. And mining rigs are computers that are used to do the minings. And nodes are every computer that collects, that are part of the networks in a blockchain and connect this blockchain together. We call them nodes. And we have cryptocurrency exchanges where there are websites that you can buy and sell different cryptocurrencies and exchange them. And most of the times these cryptocurrencies, they use initial coin offerings to sell a new digital currency or a token at a discount to raise money for their cryptocurrency, to use it for marketing and to use it to make it more reliable and secure. And there are wallets that there are software programs that you can put in your phone or in your websites. You can have it on your computer, and that you keep that keeps the public and private keys and gives you access to your cryptocurrencies. And I will talk a little bit about this later on. But why you would use the blockchain, the core idea behind blockchain that brings the most value is its decentralization. It's a decentralized system. So if you look at the centralized system, all these nodes are connected to a center. And if this center, which takes care of everything, fails, so most of the time the service fails. But in a decentralized system, so there are the different nodes are connected in different ways to each other. And then if one node fails, the system still continue to work. But what's the blockchain? Basically, blockchain is a time-stamped series of immutable records of data. And I will explain why it's immutable. And that is managed by a cluster of computers. And those computers are not owned by a single entity. And each block of data, which is a block, is secured and bound to each other using a cryptographic principle. So we call it chain, that I explained. So that's the principle of blockchain. And if you look at history, we had the idea of distributed computing in 1990, and then Satoshi Nakamoto wrote the first white paper for blockchain for Bitcoin in 2009, and then the first deployment of cryptocurrency application related to cash happened in between 2011 and 12, which basically the main application was to do transactions and the currency transfers and digital payment systems. And then later on, the financial markets saw opportunity, and we started to use blockchain technology to design modern contracts, which we call them smart contracts, that I will explain a little bit later. And then we started to work on a permissioned blockchains that you need permission to go to that blockchain for specific applications. So after the design of smart contracts, there are many applications that you can imagine to use them. And then 2018 was the boom of initial coin offerings and adaptation of the blockchain technology. But if you look at this, let's go through this example to see how the blockchain technology basically works. Let's say I'm A and you're B. I want to send money to you, right? So nobody knows basically how much I want, who I am. My identity is basically cryptographically secured. But they know that somebody, person A, wants to send money to person B, right? Or machine A wants to send money to machine B. So this transaction is represented as a block. So I want to send $2 to you, right? So this is just, basically is represented in a block, right? And then this block is broadcasted in the network. There are computer nodes in the networks, and everybody knows that, okay, as the new block showed up. And what they have to do, they have to, there are miners, basically, that they have to, they look at the information and to approve the transaction, which means that they have to see if I have enough money to send it to you. So if I have enough $2 to send $2 to you, they say, okay, yeah, he has $2 in his wallet and he can send it. So it's approved. So everybody approved. And there is a consensus mechanism to do that. And different cryptocurrencies, they have different consensus, and that makes them slower and faster and so on. And if that approved, then the block is added to the existing blockchain in a transparent and unalterable way, right? And then when it's added to blockchain, that's when the transaction happens, and transaction is complete, basically. Then my money is gone from my wallet and is transferred automatically to you. So if you look at this one, is a smart contract, is a piece of code, and is a process that basically designed in a decentralized way to make this transaction happen, which wasn't possible before because we didn't have computers available everywhere. And why is it important? Because there's no central authority. And it's, people are very interested in this concept because it's a very definition of a democratized system. It's shared and it's a shared and immutable ledger. So that makes it beautiful and strong. And information can be open to everyone and anyone to see, or can be kept private. So there are three different pillars that makes blockchain technology or blockchain itself very powerful. Decentralization, nature of the blockchain, transparency, and immutability. So as I mentioned, the core idea of blockchain is that it's decentralized in nature. So users can participate in a trustless system. So we don't trust any single user. So we have to come up with these algorithms to come up with these decisions to see if the transaction is valid or not, for example. So basically, the algorithms are that are being run in every node is being important. So and we design in a way that we don't trust any single node. And when we make a system decentralized, we lower the risk of systematic failure. Basically, it's very important in different technologies that we know that the single point of failure can halt a network, like an ATM machine or a software or a game or a service. But if it's being decentralized, if it's being designed in a decentralized way, if one of the nodes goes offline or become faulty, so the rest of the systems still are up and running. The second pillar is transparency. So later on I will explain why it's transparent, but briefly, basically. But the transactions that takes place in the blockchain are transparent. So individuals who are provided authority can see each transactions. And if you look at these ledgers, each block, the origin of any ledger can be tracked down to the chain, to its point of origin. So that's very important. So that's also a very important part of the transparency. And since there are various consensus protocols are needed to validate the entry of a new block to the blockchain, so it removes the risk of duplicate entry or fraud. With the use of smart contract, which is a piece of code, the businesses also they can preset different conditions on the blockchain, and basically when the automatic transactions are triggered only when those conditions are met. So that's also very important. The third pillar is immutability. So that provides a complete data integrity. Since it's immutable to change, and makes the auditing simple and automatic, and makes it very efficient and low cost. And you can have a proof of work. One of the main application, or the first application of the blockchain technology, was Bitcoin. So Bitcoin was invented by Satoshi Nakamoto, that nobody knows who he or she is, in early 2009. And then the currency, the Bitcoin currency, is based on a blockchain, which contains a public ledger, and all of the transactions happens in the Bitcoin network. And it started to really be taken off around 2013, and then the value increased to $20,000 by 2017, and then the value is always going up and down, and now is around, I think, it always fluctuates from $2,000 to $12,000. If we look at this, there is a blockchain process that is used in a cryptocurrency. So as I explained the fundamentals of blockchain, you can see that basically the blockchain technology is being used in most of the in all of the, in most of the cryptocurrencies, not all of them. So let's say again, someone requests a transaction, and then the request transaction is broadcasted to a peer-to-peer networks, and then the network nodes basically validate these transactions. And then after it's validated happens, then user status, basically validation happens using a certain way. It can be proof of stake, proof of work, and so on and so on. There are different consensus mechanisms to validate this transaction. And when it's verified, then it's added as a new block to the ledger. And then there's no way that we can change the blockchain or any information in the blockchain because of the way that it's designed. And it's that I will explain a little bit. And if you look at this part, the mining part, what happens during the mining, especially in the case of Bitcoin, mining is not about creating a new Bitcoin. It's a mechanism that allows the blockchain to be a decentralized security, basically. And Bitcoin mining is that it is the validation of the transaction that takes place on each Bitcoin block. And miners basically are the people who are involved in this process of verifying the transactions. And then after they verify that, they receive a transaction fee or a new newly created Bitcoin. But what exactly miners do, basically miners validate this transaction and record them on the global ledger. And if you look at the Bitcoin, a block is mined every 10 minutes. And basically miners are competing to solve a very difficult mathematical problems that it takes a couple of minutes to be solved. Basically, that mathematical problem is based on a cryptographic hash algorithms. And then when they saw the solution, when they saw the solution, they broadcast to everybody. And then they can add the new block to the blockchain. So we call it, the solution found is called proof of work. So the solution is not basically solving or looking at the different blocks or something. The solution is just a mathematical problem that's given to everybody to do, because you want to make sure that those miners have a skin in the game. So it costs them something to verify. So otherwise, if there's no cost, then if there's no stake, and then there's no trust. So if you look at the mining process, first we verify if the transactions is valid. Transactions are bundled into the block, as I explained, and then the header of the most recent block is selected, because each block has its own header. Is selected and entered into the new block as a hash. So we use a hash function, an algorithm we call it hash function, to add the header of basically hash the header of the previous block and put it inside the new block. And after this is being done, then proof of work is completed, and then the new block is added to the blockchain. So if you look at this, assume that this is a block 22, 23, and block 24, and a transaction happens. Let's say I give $5 to you, and that's the transaction data, and I have a header here. So in order to do the new transaction here at block 23, when I'm creating a block 23, a hash of the header of the previous block is added to the header of my new block, which is block 23. And then the header itself is also hashed and is being sent to the next block. That's why all of these blocks are a function of each other. And what is a hash function is basically is not an encryption. It cannot be decrypted in an original text. It's a one-way cryptographic function. That's why it makes it very strong and useful in blockchains. So the most popular hash is SHA-256 that they use it in Bitcoin. And let's say I want to hash this function using SHA-256. This is a message. And this looks like the hash of that message, right? And if I change even any spacing or a word in this message, the hash is completely changed. So the algorithm is designed in a way that any small change in the text actually changes the hash. And the output algorithm will always be 256 bits. So this is always 32 bytes, regardless of any of the size of data. The size of data can be massive, but the hash is the same. The size of the hash is the same. And there are multiple type of hash algorithms that I'm not going to focus, but you can look at it later, like SHA-1, SHA-3, or even SHA-256, which is a successor of SHA-1, and Ripem, Blake, MD5, and so on. But let's look at the, this is a hash function, but also one important thing to know and understand the cryptocurrency is to know the basics of cryptography. It's very important to know them because every person has an ID, so and that ID or identity needs to be secured. And they communicate messages or transactions in an encrypted way. So basically, if I want to make a transaction and communicate with the network, I need to send my message in an encrypted way. So then we go on to understand the cryptography, which is the study of secure and accessible communications. And encryption and ciphers basically fall under this umbrella of cryptography. And encryption is the process of turning the text into the code. So let's say I have a plain text here. I use an encryption algorithm and I convert it to this code. And this cipher is actually the code. So this is the cipher text. So now let's look at an example. Let's say I want to send a message to you. Basically, before I be able to send a message to you, I have to send you my public key. So I create a private key and a public key. So my private key is this one. It always stays with me. I don't never share my key with anybody. And my public key is the lock, basically. I can send the lock to you, but you can, if you don't have a key, you cannot open it. So my private key is always secret for me, and I never share it with anybody. But public key I can send over. So I encrypt this message and send a ciphertext to you, and also send you my lock, which is basically I encrypt it using your public key, and I send a ciphertext to you, basically, and then you use your private key to decipher that text and read it as a plain text. So if you imagine the similar applications that, let's say I want to send you an apple. Basically, you send me a box with your lock on it, and you keep your key, and then I put the apple inside the box. Nobody knows is that apple or orange or whatever. I lock the box and I mail it to you. Nobody can open the, if the lock is strong enough, nobody can open it, so nobody knows what's inside the box. And then when you receive it, you can, you're the only person that you can use your key to open it using your private key. But after all of this, it's important to know that there are three main important arguments that promote this decentralized technology. So basically, decentralization itself brings naturally brings fault tolerance to the blockchain technology. It makes it attack resistance, and it makes it collusion resistance. It makes it fault tolerant because they rely on many separate components, and all of them, most of them, needs to fail before the system fails. It makes it attack resistance because there are lots of players, and there is no central point of failure. And so if they have to attack 51% of the network in order to attack the system. And it's collusion resistance because in contrast to a centralized system, it's highly unlikely to for participants in a decentralized system to be able to collude for selfish goals. And because of the way that it's designed. So industries that are seen as a potential use of blockchain, actually the new startups, the new ideas, actually there are lots of basically startups that are using already the blockchain technology in different applications, even the car sharings, they use blockchains for to create businesses like Uber and so on and so on. But the most obvious ones are like bankings. So because blockchain is inherently is a secure system, it can provide permanent records of the millions of transactions that happens every day in the banking system. So basically, the ledger can significantly lower the risk by providing secure records to the banks. And the money also can be transferred cheaper by using blockchain technology. Real estates, basically there are real estate startups that are already using blockchain. So because of the power of blockchain, all of the documents and transaction records can be stored securely with measurably less work and less cost. And they can automate the settlement process, and they can eliminate basically a screw process by designing a smart contract. In healthcare, so there is a huge demand of sharing healthcare information. Let's say if I want to see 10 doctors, I need to be able to share my records with them easily rather than go to my doctor and get the permission, get my records and send them to the other doctors and so on. So I can be able to give permission to everybody that I want to see my records. So my records can be stored safely and then transferred safely through the blockchain. Another industry is legal. So there are also startups that are using these technology for storing the records. The records can be basically stored and it can be verified. So it makes it much easier to deal with inheritance, even including cryptocurrency assets. In politics, there are countries that started to use this blockchain for voter registration and verification of identity. And it would count the votes to ensure only legitimate voters were counted, because each voter has a unique identity. And the video industry, it's like, it's a big industry, and the video traffic costs a lot of money, and which is the 82% of all internet traffic. So the blockchain technology can play an important role in providing a decentralized video infrastructure. So there are different areas like digital currencies, record keeping, securities, and smart contracts, and each of them have their own applications like e-commerce, payments, lendings, microfinancings. In healthcare, record keeping's application of the blockchain can be used in healthcare, title records, ownerships, votings, to record any intellectual properties. Securities of the blockchain can be used for equity, in private markets, in debts, crowdfundings, and derivatives. And smart contracts can be used in many, many different applications like digital rights, wagers, escrow, and so on. There are three different type of blockchains. So public, private, and consortium. Publics are anyone in the world can take parts in the consensus process of a public blockchain. In a private blockchain, only a limited number of organizations can participate, and they need to have permissions, and generally organizations, they use them for auditing and database management and enterprise content management. And we have a consortium, which is a hybrid form of blockchain, which is in between the public and private. So basically the consensus process is controlled by a predefined set of nodes, not by everybody. So there are different use cases of blockchain and fintech. So one of the most important use cases is smart contracts. So smart contract is a computer code running on the top of the blockchain. And a smart contract contains a set of rules. Those are the rules that the parties in the smart contracts are agreed to interact with each other. And when these predefined rules are met, the agreement is automatically enforced. And there are different applications. Sure, I have 5 minutes. I got the message. So, and the fintech, another application is digital payments. So transfer of value or assets has been always slow, especially if it's international. It needs lots of banks and institutions and middle people there to process this transfer of money. So we can do that using blockchain technology. Digital identity is very important. So identity management is very important application of blockchain technology. And users can able to choose how their identity, how they identify themselves and with whom they can share their identity. And basically that also reduce the cost of sharing identities. Share trading is another application of blockchain, like buying and selling stocks and shares involve many middlemen again, and like brokers and also the stock exchange itself. So we can remove the middleman easily using the blockchain technology. There are predictions that by 2030, these are predictions, we will see a rise of government cryptos. So if you see, there are already governments around the world that are moving to crypto. So by 2030, most governments around the world will create and adopt some form of virtual currency. This is already going on. We can have trillion-dollar protocols, like there will be more trillion-dollar tokens than there will be more trillion-dollar companies by 2030s. And we will have a blockchain identity for all. So it's a cross-border blockchain-based self-sovereign identity standards. And most of the world trades will be conducted leveraging blockchain technology. And there will be significant improvements in the world standards of livings by using the blockchain technology. But this is my last slide. If you want to see if you want to see if you want to use a blockchain or not, basically we can go through this algorithm. So let's see. Do you need or want a middleman? If you don't need, no. If you need a middleman, yes, you don't need a blockchain. If you don't need a middleman, then ask this question: do you want to work with digital assets? If it's yes, then ask this question: are you able to develop a permanent solution for the digital asset? Is yes, then do you need a common shared database? If it's yes, then ask this question: Are you working with multiple parties? If it's yes, do you want a trustless environment? If it's yes, do you need high performance? No. Then does your requirement include a large storage unit? No. Are you looking for contractual solutions? Yes. Do you require no change or little change in rules on the system? Yes. Then do you need, basically these are smart contracts, which are flexible and can design them. Do you need shared right access? Yes. Do you need control over the functionalities? And if yes, you go to blockchain, private blockchain. If no, then you ask these questions. Want transaction public? If it's no, build your own private blockchain. If yes, then you can use a public blockchain. So you have to go through all of this screening to see if your application is suitable, or if blockchain is suitable for your application. There are references here that we used to prepare these slides, and I thanks my PhD students, Shayan Sariri, to help me. I will share the slides with Ellen to share with you guys, just in case. But thank you very much, and mahalo for your time. And
yeah, thank you, Dr. Reza Ghorbani. We have actually one question for you from Lal at DBAT. And sure. If you refer to the question, it's in your chat, but he's asking, how are we able to apply blockchain or blockchain technology to track Hawaii-made products?
So supply chain is very important, actually, applications of blockchain. So there are different ways that you can use the blockchain for basically you're using it at certifying the authenticity if the product is made in Hawaii or not, right? So basically you have to give an identity to that product first. And that's a first challenge, and that's not an easy challenge. And then you have to document the process that product is being made, and basically post it in a public blockchain. Basically, evidences that shows that this fabric or this clothes or whatever is made in Hawaii. And you can build a ledger to verify that yes, all of those requirements are met. You can design as a smart contract, and then when all of those are met, then you can give a thumb up and say, okay, yes, this is made in Hawaii, and you can post it somewhere. And if people want to see and check it out, they can basically look at this. Basically, there's a way to verify that yes, all of those processes are already verified by different nodes. So it's not very straightforward, and it needs different. It involves different nodes or sectors, or to check the authenticity of that process of manufacturing or building that product, and then you can put that information in your blockchain.
So I think the question will also be, how granular do we have to go down to, right? For example, if you're saying like a Aloha shirt, does it start from, I don't know, the material itself? Does the blockchain start from there, or how granular do we have to actually lay the groundwork for?
Yes, I mean those basically you need to design a verifiable way to verify that fabric is made in basically in Hawaii, or made in this place, and you need to record it. So the record can be kept in the blockchain, right? And it can be publicly, people can publicly check it out. which is already verified. But you need trusted. You need to build a trusted entities that they basically they put those records in your blockchain. So if you can trust timestamps and GPS of any information that you get during that process, you can put in the blockchain. Let's say you have a picture of your facilities, or you have a way to verify that that product is made at this time, at this location. So it's still, you need to have your trusted individuals to verify that, to put the information in.
Okay. Lau, did we answer your question? If we did not, you can send in, other sub questions. We have 5 more minutes, so we are still accepting questions. But as we wait for more questions to come in, I have one for Dr. Reza. So what would you say, I mean, blockchain has all its advantages and benefits. What would be one of, I would, you would say is a limitation of blockchain?
So blockchains, the transactions are not very fast. But the emerging way of consensus algorithms make them very fast. The size of, the blocks can be limited because you have to have also copy of each block everywhere. And also if it's not very well designed, it cannot be very secure at the beginning. So you have to make sure that you do your math right and all of those. That's why people start to write their white papers about their algorithms to make sure that it's correct, so that there is no flaw in it. But I would say the first one is basically they're not as fast of a centralized system. So that's the main limitation.
Thank you. So any other questions? Oh, there's a question from Joanne. Mm-hmm. Can you see it on your end? Yeah. So she's saying, can you recommend the best way to get started? Is there an API you would recommend? Do we have to pay for services?
Oh yeah, that's a very good question. So there are different, it depends what you need it for. So like if you want to use the public ledgers or you want to build your own private ledger. So if you have a public ledger, you can use like something like Stellar and you can build on it. And it depends on what you want to use it, depends on your applications. Yes, you need to have some form of backgrounds in computer programming, and then you can basically write codes to communicate through their APIs to these ledgers. And there are programs, there are tools that are being available, like one of them is I think Simba Chain, that tries to make the smart contracts very easily, like I can simbachain.com. They try to make this smart usage of smart contracts very easy. So I think if you look at that, it might give you some ideas, but it's not straightforward at the beginning. That's the challenge of using blockchain.
Awesome. We have one more question. It just came in from Jericho. So Jericho is asking, which blockchain languages or frameworks are most used in developing current solutions?
Oh, Ethereum is a good ledger. If I understood your question very well. Stellar is a very good one. So IOTA, they have their own issues, but they're very fast. They're built for IoT devices. So again, you have to look at what your application is. So each ledger is designed for certain applications. One of them, like Stellar, is designed for international transactions. Ethereum is built for something else. So you have to know your application, and then you have to choose them. Choose the best one that suits your application.
Great. So I think, we are almost coming to the end of the session. Thank you for sharing, your knowledge with us today.
Thank you.
If there are any newbies who want to learn more about blockchain, where is a good place to start?
I can send you a couple of different, resources. And also, if you look at this, at the end of my slides, you can look at all of these sources that I used to read them. So that would be very helpful.
Okay, great. So do you want to, Dr. Reza, do you want to leave your email for people to contact you directly?
Yes.
Would that be okay?
Yes.
If you want, you can leave it in the group chat. So everyone, Dr. Reza's leaving his email. So take it down. If you have questions that you want to ask him, feel free to send it over directly to him.
Oh, it's privately. So let me send to everyone.
Yes.
Hawaii.
Okay, so let's see once it comes through.
Yes.
Awesome. Okay, so it's rezag@hawaii.edu would be Dr. Reza's email. So we have come to the end of our session today. I hope it has been helpful for a lot of you to learn a little bit more about what blockchain is and some of its applications. If you have other ideas or things you want to learn about blockchain or blockchain in financial technology or cryptocurrency, digital currencies, feel free to email me. I'll leave my email in chat as well, and we can figure out, the next topics that would be interesting for everybody. So we've come to the end of session. Thank you so much for coming today. And thank you again, Dr. Reza, for making time for us.
Thanks, everyone. Thank you. Have a great day.